and welcome to our YouTube channel. Today we'll be discussing a very interesting topic, which is machine learning, and we will see how machine learning works and discuss a very simple program of machine learning. So first, what exactly do we mean by the term machine learning? So is as literal as the word can get. Machine learning is a method in where computers learn patterns from data. So what happens is, just like in humans, when we see a set of data, our brain automatically tries to figure out the patterns in them. Same thing is what we are trying to implement, but using machines. So in this method, in machine learning, we feed the computer data, and the computer automatically takes the understands the pattern, learns the pattern to predict future values based on that pattern. And so the important thing to note here is they are not explicitly programmed to detect those patterns. They automatically learn. And it's very interesting. If you can look up more detailed videos on how this works, I'll give you a simple example. So machine learning. So basically what I mean to say is AI, artificial intelligence, you can also call it that. How do we actually visualize it? So just like in a human brain, we have multiple neurons, and neurons are either, you can imagine them in being in either of the two states. Either they are off or they're on. Either they are dormant or they are sending electric signals. So in a similar way, what we do is we create multiple neurons, artificial neurons, and each neuron can either be on, that is 1, or off, that is 0. And now we make multiple of these neurons, xn, so that I have 1, 2, 3, all of these are single neurons, and all of these are connected to each other. These are also neurons, they are connected to each other. So this is the input, this is what we call the input layer. So whatever data we feed it goes inside of these, and this is the hidden layer. So hidden layer is basically, that is not that is something which does the processing, and here we have the output. So we feed it some data and we feed it some output, so the computer can recognize the pattern. So basically that will go here. Computer will recognize the pattern. It will since it's a logistic regression model, what that means is basically whenever let's say I give it some value, it will try to guess what will come next, and if it is correct, it is rewarded, and the weights remained unchanged, the parameters remained unchanged. And if it gets wrong, it will go send a signal back that the prediction was wrong, we need to update the parameters, and it will update the parameters to make a new prediction. It will continue on happening again and again until the prediction comes out to be right. So this is how AI, artificial intelligence, is trained, and this is how it works. Exactly like, not exactly, it's very similar to how a human brain works. That is how we have modeled it. So let's get to the program. So this is a simple logistic regression program. So it's as simple as machine learning can get. And we have import torch. So torch is a library in Python that allows me to use GPU for training, model training and all. And it also allows me to create AI models. So torch can also run on the CPU, but torch can also run on the CPU. It all depends on what device you have on your computer. So if a GPU is available, it will shift to GPU, but you will need to specify that I want to move to GPU. I want to use the GPU. Otherwise, by default, it will stick to CPU for execution. So I'm just, this is all the import, and I'm just importing all of the required modules. This is for model creation, and this is for optimizers. this module is for optimizers. So now we have device is equal to torch.device. So what I'm doing is I am setting the device that I want to use for model training, and I'm setting it to CUDA. So CUDA basically means GPU. I want to use the GPU for model training if torch.CUDA is available. So I have also put a if statement. If a GPU is available, use GPU, else use CPU. Okay. And it will print what device I am using, and just give me, it will, when the program is running, it will give me that since this device is not available, we'll be running on CPU, or CPU is available, we'll be using GPU for the program. Okay. Next, I have defined the data sets. So X is basically in the input. So torch.tensor, and I have defined 4 inputs, 1, 2, 3, 4. So that means X, the value of X changes 1, 2, 3, 4 changes to all of these values, and to device. That means I'm sending this tensor. So since we are working in AI, we use tensor, not normal vectors, and it will be sending this tensor to device. Device basically means whichever device is being used. If CUDA is there, CUDA. If CUDA is not there, then CPU. And y is equal to torch.tensor. So these are the outputs of the equation that I am trying to teach the computer. So one, basically what this means is, if x is equal to 1, y is equal to 3, x is equal to 2, y is equal to 5, x is equal to 3, y equals to 7. So basically this equation is 2x plus 1 equals to y. And I'm trying, and I have given the values here according to that equation. And I'm sending this to the device. And now we are creating the model. So model is equal to nn dot linear 11. Linear 11 means I just need one layer and nothing too complex. Since it's a very simple program, 2x plus, it's just 2x plus 1. And I'm sending this to the device as well. And this is for optimization and all. So basically means the program, and so the model needs to come back. It's like here in the hidden layer. If there is some kind of, let's say, error in prediction, it will give a signal back to the hidden layer to correct it, to correct the parameters. So that's where the optimizer comes in. It will tweak the parameters to change the output and to get the correct output basically. Here we have defined epochs. So I'm running this program for 1000. Since data is less, so it's better to run for longer epochs so that the program can get better trained. And now this is just a for loop, and epochs, we have y predict is equal to model x. So y predict is basically what the prediction that the model will make, and model x is this value of x. Loss is equal to criterion. So criterion I have defined NN MSE loss. So this will calculate the loss of the, basically the difference in the predicted value and the actual value of y. And then optimizer 0 grad, it will optimize, it will reset the parameters, reset the optimizer. Sorry, it will calculate the gradient of the, calculate the gradient between the y pred and y, and optimize the parameters based on that gradient. Optimizer.step, we are changing to the optimizing the parameters here. Then we have if epoch is percentage 100. So that means if epochs are all completed, then we will print epoch this and epoch that. Okay. And loss or loss that. So it will tell me which epoch it is and which loss dot item. That means which so what's the loss that was observed in this occur. And then we are testing the model. test x, so torch.tensor 5. So that means I am testing it for 5, and I have test y model test x. So model is now created, model is now trained, model bracket test x. That means test x is torch tensor 5. So that means 5 will be substituted here, and it will give me a predicted value of x equals to 5. Okay, let's see a live demo of this program. So I'm currently logged into the Paramrudra HPC, and I'm in the GPU node right now. And this is the program that will be executing. So first, I will need to load Miniconda module in order to run Python. It's a requirement of this system that I'm working in. It may not be so for the system you are working on, and you might be able to just run it natively using CMD or a Python interpreter. And now I will need to load load a environment. So I'm using this environment as it has all of the modules that I want to use in this. And I will Python 3 ml program.py, and let's let the program run. It will take some time to execute, and we'll have to wait for it to finish. It is taking a while. So since it's not a simple Python program, it's a bit complex, and it needs to create a model and train it as well. It is taking a little bit of time. And Python already is not a very computer friendly language, as it needs interpreters to be converted to the computer code. Yeah, finally we have got some output. It says print device using CUDA. So that means it is using the GPU. That is possible because I'm in the GPU node right now. I think now it's going to take even more time because we'll be in the epochs range now. Okay, it's kept. Expected all tensors to be on the same device. Let's just remove the CPU part. I think maybe it is causing problems because I'm sending data to GPU, and is saying not all tensors are in the same place. No problem. We'll just remove all the GPU. all the parts that are transferred to GPU. Yeah. So I've got output now. It says prediction for x is equal to 5, 10.9974. So the equation that we were testing is 2x plus 1 is equal to y. So it is very close. It should be 11. Ideally, it should be 11, but it's saying 10.944. Let's do one thing. Let's try changing the epochs to, let's say, 2000. I might be overfitting the model here, but no worries. We are testing and we should test at the extremes as well. So let's see. Now it's saying 11 point. So model got better instead of getting worse. That's a good thing since the model is getting more and more accurate as I'm increasing the epochs. And it will also be same if I were to increase the data set. Then I can reduce the number of epochs that I'm working with. And because if I have a larger data, the model will be easily able to pick up the patterns. Meanwhile, as in this case, I only have four data. So basically 4 values of x and likewise 4 outputs of the same. So it will be a bit tough for the model to predict, to learn based off only 4 values. So that is why we need a large number of epochs. So let's try changing the test value to 10. Let's see what output we get. Ideally, it should be 21. So it should be close to that. Yeah, 21.00. So it's within 2 decimal range. So that's very quite accurate. You ask me, we in physics and all, we consider up to 2 decimal range to be accurate. So that is it for this video. We talked about what are ML models, what are how they work, how they function, how they are modeled, and how you can use Python to create ML models of your own. Thank you for watching, and do come for the next one as well.